Welcome to Metapod, the podcast where we discuss operational execs and organizations that make and move stuff, and our common headaches, digital transformation, the forever labor shortage, and doing more with less. And now, the host of Metapod, Ron Crabtree.
It's Ron Crabtree here, back with another episode of Metapod, where we dive into talking with thought leaders from around the world around these three common challenges that manufacturing, industrial organizations dealing with capital goods, tangible goods any kind, particularly in North America, but most of the world for that matter, is, the forever labor shortage, the fact that, the growth of the workforce is continuing to contract for foreseeable future. Then digitization, digital transformation, AI being the topic of this particular podcast, and how we can better leverage that in manufacturing. And then just needing to do more with less people, resources, etc. So I got Bryan DeBois here with, he's the director of industrial AI at novices, and I'm going to ask them, novices, and I'm going to ask him to introduce himself here in a moment. But I think you'll really find this episode pretty interesting if you're thinking about these kinds of challenges, right? Rely on a lot of tribal knowledge to get things done. And that's a real challenge with the exit of the boomer workforce in the years to come. Struggling with onboarding and training, facing a wave of retirements, turnover of the workforce, needing to reduce downtime and mistakes, particularly the human error part, and maybe curious about, how can we actually make a difference by leveraging AI? So I think you're really going to enjoy this. I know I will. So Bryan, tell us a little bit about you.
Yeah, great to be here, Ron. So as you mentioned, Bryan DeBois, Director of Industrial AI for a company called novices. Now, we are an OT system integrator. So what does that mean? That means we're focused on the plant floor. We're focused on manufacturing and industrial customers and how they can do more with less on the plant floor primarily. So we don't get into a lot of the ERP level types of things and supply chain and the higher level decision making. This is really about how can we push more product through on the plant floor? How can we optimize these processes? How can we reduce scrap, reduce energy utilization, reduce those costs, and increase profitability? And really, we see the plant floor as the heartbeat of any of these manufacturing facilities, right? There's a lot you can do in terms of master data management and optimizing supply chains, and all of that's important. But if you can't make product, you can't make money. And so we're really focused on that. My background, I've been with novices my whole professional career. So I co-opted here and then I started full time. So I've been with novices for 25 years. And so really came in, I had a computer science background, really came in not knowing anything about manufacturing, but have since fallen in love with manufacturing. I've been on a lot of plants, as you can imagine, and seeing how things get made. And so then about 6 years ago, we started this industrial AI division. And the goal with that specifically was to bring AI and these advanced technologies to the manufacturing space, which has traditionally been slow to adopt some of these more cutting edge technologies. And so I really see, as an independent system integrator, I really see my role as to kind of break through the hype, cut through a lot of the marketing jargon, and try to get to here's how these things actually can impact the plant floor, and here's how they can actually be put into operation in a facility that has to run 24/7, right? And so we're very cognizant of that fact that we've got to keep these plants running. We cannot jeopardize the productivity of these plants. So anyway, that's kind of my background.
Awesome. Thank you for that. What I'd like to do now is pivot into a diagnostic, if you will. I've asked Bryan to put together his thoughts around what are three key areas the average manufacturer should be thinking about, particularly out on the shop floor, that we should be looking at and evaluating. Do we have a gap here? Is there a threat to this organization if we don't act? Or is there a big opportunity, on the backside? And assuming your audience doesn't know a whole lot about all that stuff, so we've got to kind of educate our audience and just help them understand, is there a gap? How do we measure that? How do we go out there and ask the right questions to determine whether we're far enough along with these sorts of challenges? So Bryan, why don't you jump in and talk about what you would look at and why and how we'd measure it?
Yeah, for sure. And so I'm really kind of focused on 3 different areas here. So I'm gonna be looking at expertise loss and that tribal knowledge in particular. I'm gonna be looking at decision-making bottlenecks. I'm gonna be looking at missed optimization opportunities. I think those are the 3 areas that when I talk to clients, those are the areas that they like to focus on. So I try to focus on that as well. So let's talk first about that expertise loss. And it's no secret, right? When I talk to my clients, it's the number one thing that they lead with is that we are losing our best experts. A lot of folks are talking about this silver tsunami as primarily baby boomers are retiring in droves post-COVID. LNS research, and I quote this a lot, but LNS research put out a study in 2019. The average tenure in the U.S. manufacturing workforce, the average tenure was 20 years. By 2023, it dropped to 3 years. Oh, that's a huge loss. And so what are the kinds of questions that we ask? So we're going to ask what kind of decisions or tasks depend on a specific person's expertise. What I'll say to people is if one or two people, when the bill is going to be running, that part of the process today, we're going to have a good day. But when Frank's running, he's a little newer, we may not have as good of a day, right? Where are those processes? That's a red flag that, okay, now we've identified something that is it more of a tribal knowledge? It's more of an art than a science kind of thing. So how can we leverage AI to try to augment that capability of those newer folks, of those novice operators? So I'll tell you a quick story. I was up in Canada. I'm at a vinyl extrusion plant. And I walk in and I'm talking to the plant manager, and within 5 minutes of us talking, he said, I've got 2 guys who know how to run this vinyl extrusion line better than anyone. And they're both 5 years from retirement. And he said, I got no bench. I got 6-month, 1-year guys. I've got high turnover in these positions. He's like, I don't know what I'm gonna do, right? When these guys retire. And the reality of it is, and it's a generational thing, but nobody wants to spend the next 10, 15 years of their life learning how to best optimize a vinyl extrusion line. And we can wish that it wasn't that case, and we can certainly hope that things change. But for him, he's got to live with the reality that I'm either going to adopt some of these advanced technologies like AI to try to help my novice guys be able to run this line as well, or I'm just going to live with the fact that the line's never going to run as well as it does today. And that's a bad place to be when you're looking to the future and saying it's never going to run as well as it does today. So you're looking for who holds the critical knowledge. You're looking for, if you're losing 20% or more of your experienced workforce within, five years or so, those are the types of signals that we're looking for. And then how are those decisions? Do you have a way to track the conditions leading up to those decisions and how those experts are responding? Because that's how we're going to then train the AI to be able to respond in the same way as those experts. So we do a process called machine teaching. We leverage that historical time series data, but we marry it to what were the decisions that those experts made. And the combination of those two things then is expertise, right? Looking at something, responding to it, and then, acting in an expert fashion. If we can capture that, that's how we can capture those expert decisions in Silicon and then never lose it. So that's kind of what we're looking for there.
Yeah. So one of the questions I have here is, I had a really interesting guest in my podcast the other day, and something he opened up my mind to. He's actually out of Australia and came up with doing some of these things without some of the fancy Lean Six Sigma jargon laid on top. And talking with him is like, you got to somehow get a basic document set to feed AI. And if you run into that, where do we have even the basics of documentation that we can feed our AI? Is it SOPs? Is it job description? Is it task duties? Is it just simply recordings?
Right.
People that, are actually doing the tasks. I mean, we got to go out and find out if we actually have that to even get started, because without that, it's a non-starter. I mean, you got to feed AI with something, right?
Right. And I didn't hear that particular episode, but my guess is based on that description is that he's coming at it with a certain angle, and that's going to be about leveraging generative AI and LLMs. And I get that. And those are knowledge problems, and there's a lot of important knowledge problems that need to be solved in the plant as well. I'm coming at it from a different direction. I'm basically saying I already know that none of this stuff is written down because I've been in this industry long enough to know that, right? But we don't necessarily have to have that. What we need is we need the historical data of how this plant has operated in the real world, and we marry that to the expertise that's in the head of that expert. So we're capturing that expertise before that person leaves. So we're sitting down with that person and we're saying, train me the same way that you would train a new operator, and then I'm going to program that into the software. So we do a process. This process is called machine teaching that I'm describing. And basically, when we're done with that, what that expert will say is things like, well, when the line's running hot, we tend to do this. And when the line's running cool, we tend to do this. Honestly, stuff that you're probably not even going to get in an SOP anyway, right? These are the tips and the tricks and the heuristics and the skills that you would tell somebody, that would teach somebody if you're trying to tell them how to run this line, but you're not ever going to really write it down. So when we're done then through that machine teaching process, it almost looks like a workflow of skills. And then what we're doing is we're giving that skill set to this tool that we use called autonomous AI. It's based on deep reinforcement learning. And based on that, it can actually learn how to run the line as well as that expert. And in a lot of cases, we've actually been able to train these agents to be able to outperform those best operators, the same folks who helped train it.
All right. So you went by a couple of acronyms really fast there. I think you called it generative AI or regenerative
AI. Yeah.
Define that, at least how you would define it.
Yeah, and it's important. Yeah, it's definitely important to understand because there's, everyone kind of lumps AI into this giant umbrella, but the reality of it is different kinds of AI. So generative AI is an umbrella term that encompasses everything like ChatGPT, which is what's called a large language model or LLM. You may have heard that term, but also generative AI includes any of the image generation and the video generation technology that we see coming out. The advancement, the insight that have made generative AI possible was an algorithm called transformers. So transformers is at the heart of generative AI. It makes all of those cool things possible. Autonomous AI, which is distinct from generative AI, autonomous AI has been around for about a decade, and it came out of DeepMind, which was a Google spinoff, and that is built on a technology called deep reinforcement learning. And that is where we can actually set the AI agent up in an environment where it can play safely. So this is a simulated environment. So we're simulating part of the process. And then that agent can learn by doing. And so we will typically train an agent on average about a day, a human day. By the time it's done, it's like it's run that part of the process for 20 to 30 years. So it becomes an expert operator, and we feed it all those heuristics we talked about through that machine teaching. We feed it all of that. So then it's got kind of a starting point, same way like you would with a new operator, but now it's going to try all kinds of things that maybe a human wouldn't even try. And it's going to have catastrophic failure, but it's in a safe environment. It's in a simulation, and we penalize it heavily when it blows up the plant. But it's also going to be rewarded for finding new ways to run that process and squeezing every little bit of performance out of that part of the process. Those autonomous AI agents, we've got real ones running in plants today. So this is not pie in the sky. This is real in production stuff. Those autonomous AI agents, then that's the mechanism. Then we can put that into a decision support system, even if we don't have it running directly on the plant. We can put it into a decision support system so that's looking over the shoulder of a newer operator and saying, hey, you should do this. Hey, you should do that. Hey, you might want to think about doing that. And those types of insights, that's where real expertise comes from.
All right, that's cool. Let's pivot now to this next diagnostic, something around losing of knowledge to attrition or turnover as a diagnostic.
Yes. Yes. So, when you're looking at your workforce, hopefully, these manufacturing customers are looking at how many, what is the percentage of folks I'm going to lose in the next 5 years? And I think when they're doing that, what they're finding is that they're not finding this influx of new talent that's coming in. They're finding that there's a lot of turnover, and folks don't want to become experts on this. And so where they're having to make changes is around really, and I hate to say this, but it's kind of true, is we kind of have to move towards a McDonald's style process of making these plants run in a way where you can hire practically anyone off the street and they can come in and they can be successful. Now, how did McDonald's do that, right? Well, they basically automated every aspect of it. There's not a lot of thought that goes into making a Big Mac, right? Like you have a very strict SOP. You've got automated systems. Like they're not really cooking things in the way like at a diner, you would where there's a certain amount of skill you need to be able to run a flat top. Like they're putting frozen patties into a machine. The machine is calibrated to do everything, all the seasonings built in, everything's there. That's a I mean, for better, worse, indifferent. Again, we could argue the merit of this, or we could just live with the reality that this is the level of automation that we're going to have to get to in these plants. And I think that a lot of people, this because you've been in these facilities. I know this, but I think a lot of people outside of our world don't realize how little automation we have in a lot of these facilities. You've got the Amazons of the world, and yes, those videos coming out, and I've been in the Amazon facilities. They're amazing, right? But that's not representative of most of the factories that exist today. They are still highly manual, and there's still a lot of art, not science. There's still a lot that where the quality of the output relies on the skills of the person operating that part of the process. Well, those skills are being lost. So now what do? Now you've got to get to a point where anyone can come in off the street and be successful and produce high quality products. And how are you going to do that? We're going to adopt more automation, and you're going to adopt more AI to be able to get there.
All right. So one of the things I've talked about with some of my guests is, I'm just going to ask questions kind of off the wall here.
Yeah.
Right. So one of the techniques that's been around forever is what's called the versatility matrix, right? You kind of list down and keep maybe like a spreadsheet. Left-hand side, we have the names of our people, and across the top, we've got the skills, abilities, et cetera. And then we evaluate how proficient are they today and where do they need to be in the future with all those skills and abilities. And that's dynamically changing, right? Because now it's like, okay, what it looked like 5 years ago, what it needs to look like in the next 5 years is dramatically different, with the advent of digital transformation, if nothing else. Have you had any success using AI type tools to do that sort of analysis, actually creating a skills matrix and doing some gap fitting? Jenny, ever tried to do that?
Not yet. And I think that that's where generative AI is going to start to help when you're talking, because again, that's more of a knowledge type of thing, right? And so that's where consultants like us, that's our bread and butter. And so we're looking at leveraging, the generative AI tools to help make our jobs a little bit easier and to accelerate those types of consultancy engagements. Uh,
This man's giving you a great idea to proceed because I don't think anything's to do that. Yeah, I don't think anything exists to do that really effectively, and it's a huge problem. The HR community grapples with this every day because they got this huge organization that needs support, but they don't know who needs to do what and at what level. I have no idea. So there's struggle with how do I extract from, our manufacturing organization what I need to know from an HR perspective to actually be dialing in our workforce development strategy. How are we going to attract people to even get hired? How are we going to keep them if we get them? And oh, by the way, what do we need them to know? So I find that pretty fascinating. So let's jump to that third area you wanted to get into diagnostics around how we capture expert decisions, etc.
yeah. So, and I kind of touched on this a little bit, but just to kind of recap. So you're going to have to look at how you're tracking that data today, and how those key decision makers, those experts, how are they making decisions in response to that data? So we're going to have to get both of those. The data typically we have. So historical time series databases have been around in our world for a long time. And it's funny, when I started my career in the early 2000s, we were still kind of educating folks on what a historian was. Why would I bother to save all this data? What would I ever do with this data? And now, fast forward 25 years later, most people have historians. They have typically multiple historians. So we have the data in a lot of cases. Mixing that though with how we get to quality. So now we've got to go look at quality systems to be able to incorporate that data in, but then also talking to those experts and finding out, okay, how do you react when the line does this? And then we can capture that. So it's the marriage of all of those things. What we're looking for, if experts are making decisions based on phone calls or, just their intuition that they've built over the years, that's where we can potentially have those interviews with those experts and capture that expertise.
All right. Well, that was awesome. All we did this so far here was really kind of talked about this general, you know, what do we do about the loss of tribal knowledge, right? So let's jump to that next big area, which was, decision-making bottlenecks, and what should we be looking at and assessing in that vein?
Right. So so typically, there's a couple different things we look at from a diagnostic standpoint. So where are decisions delayed or where are they inconsistent? So where again, you come back to if the shift lead is somebody that you can trust, you know that they're going to make quick decisions and tend to be the right decisions. Whereas if there's, another shift lead that it's like, oh, I don't know why he's doing things the way that he's doing it. So if there's a lot of disputes between shifts about how things are handled, that's something where we identify that, okay, well, these decisions are primarily requiring manual judgment, and there's a lot of variability between shifts. So that to us is a red flag. Secondly, our operators, are they reacting instead of anticipating? Right. So we really want, ideally, you want it's kind of like when you were taught how to drive a car, right? So one of the things they taught us is you shouldn't just be looking at the taillights of the car in front of you, right? You want to be looking 3 cars in front of that person, because if they slam on the brakes, you know that that's going to come back to you. So that's the difference between being able to anticipate that something's going to happen versus just reacting. And again, I see it a lot when I walk into these facilities, that it is a lot of just reacting to what's happening, rather than anticipating the problem. So we can employ things like predictive AI. So this is another category of AI. We talked about generative AI, autonomous AI. So we've got predictive AI. And predictive AI is just about looking at the existing data that exists and basically building a model that can predict what is going to happen in the future. So what is the final quality of this batch going to be? If I can predict that with 95% certainty that this batch is going to need to rework, or that it's going to need maybe to be scrapped, if I can predict what that final quality of this batch is going to be, I can do that well before that batch has to be scrapped. And so now I've given those operators, those supervisors, I've given them the time to anticipate a problem and be able to actually respond to that problem, rather than react hours later, maybe days later, after they get the results back from the quality lab. And then the final kind of, again, red flag that we're looking for is an over reliance on kind of rules of thumb. If that operator is using a lot of undocumented logic, if they're doing a lot of mental math, if there's not a lot of written decision criteria, if it's just kind of rote, I just follow this plan and I don't really think about it. Those are the types of areas where we can find that we can optimize processes. So let me give you a story there. So we went into a hydroelectric dam. And, the big thing, the customer told us the water is the fuel, right? In a hydroelectric dam, the water's the fuel. And so the decisions that operator is making is, well, how high and low do I open these doors to allow more water through? And it's not just about, that, but then also they have a decision-making ability to send that water to different turbines, right? Well, each one of those turbines runs at a different, what they call efficiency curve. And so how should I send this water down? Should I send 60% of the water to this one and 40% to this turbine? How should I divide it up? I know I've got to hit this many megawatts of generation. What's the best way to do that? And I said, well, how do you make that decision? Well, he said, I've got this little cheat sheet. It was literally taped to the side of his screen. And it says if I'm making 80 megawatts, I don't remember the numbers, but let's say if I'm making 80 megawatts, then I'm going to send 20% to this turbine. I'm going to send 30% to the water. I said, well, who made that up? Right? Well, I don't know. He's like, that's been here as long as I've been here. And I've been here for 15 years or whatever. So like, no one's ever questioned that. Right? So that's just where you get to this, somebody kind of paved the cow paths, and that's just kind of how it went. And so no one's ever questioned that. So those are areas where we know we can make big advances by putting an intelligence system in there that's going to not say 20%, but what if it was 18.75%, right? What if it was 21.3%? AI is not bound by round numbers like humans are. Like, it will go ahead and make those micro adjustments in real time. and be able to carve out, we've seen double-digit percentage efficiency improvements in these types of systems just because the AI is going to go ahead and make those micro decisions constantly. So those are the three areas as far as decision-making bottlenecks that we're typically looking for.
Yeah, something you said there was pretty important before we go to this next diagnostic. Something you said there is important is what I've observed over many years, in multi-shift operations is first shift is ending, a second shift's coming in, and we need to observe. So if the first thing you do is start tweaking how the machine is set, that is a massive red
That's a huge
flag.
red flag.
Massive red flag because, everybody that's like, "Hey, we're using tribal knowledge here to run this business, and
Right.
is that really in our best interest?" So I found that one really good observation. So what else do you have for a diagnostic before we jump into what to do?
Yeah, so the third one is about missed optimization opportunities. And again, after customers talk about the loss of expertise, this is typically the next thing they go to is we know that we could be more optimal. And we know that we're missing opportunities. And so where can we, make better use of our data and things like so? Again, so the first thing as we look at the analytics tools that they're using today, if they're using any at all. A lot of these companies have not really broadly adopted any kind of analytics culture and data-driven culture. So we look at what analytics tools they have and look at the data that they've collected and what decisions are being based on real data versus tribal knowledge. So I've got a story there. I had a company and they forge aluminum wheels. And we went in there and, they were a company that were actually focused on continuous improvement, right? And you don't see that a lot. So that impressed me culture-wise. But so they had continuous improvement dollars allocated every year. And I said, "Well, how do you decide where those dollars go?" And they go, "Well, it kind of goes to the loudest voice in the room." So we know going into these meetings who's going to end up getting the money because it's going to be so and so who's, the loudest voice. So we did a bunch of data projects with them, put in new analytics systems and new optimization systems. And by the end of that, about a year later, I had a conversation with the same guy and he said, "You know what? What I love about this is that this has taken us from where we were to a data-driven culture. And now the decision about where those continuous improvement dollars goes, it doesn't go to the loudest voice in the room. It goes to who can build the most compelling story based on data." And that's really where you want to get to. So that first thing about missed opportunities is, are you making full use of your data? Are you leveraging analytics tools to make decisions, or are you just using gut feel? The second thing is are you relying solely on dashboards instead of that closed loop intelligence? So are those dashboards, are they just there on the screen and no one really looks at it and it's just a visualization of data, or are they actually guiding decisions? I've got a customer, they mine lithium and process lithium, which obviously is really important nowadays. They don't have dashboards. They have what they call action boards. And the idea behind that, it's subtle, but it's important, is that everything on the board has a button underneath that you can press it to take action based on that, right? And they also have a smaller button next to every single graphic on the board that you can press and you can report back if it's a nuisance alarm or something like that. And then they have, I mean, think about the levels, the meta levels here. So they actually have then a Power BI report at corporate that captures all of those nuisance alarm reports and shows heat maps like a hotspot, like we need to go to this plant because they're continuously reporting that this is a nuisance alarm. How can we better change that action board so that it responds better to the types of information that they need to be able to make decisions? So I love that. I love that approach. And that's the difference between just taking that data as a static or actually building it in a way where people can actually act on it. When you're staring at a dashboard waiting to notice that something's wrong, that's passive monitoring at that point. And honestly, we can build AI to do that. There's not a lot of value add in doing that, right? It's about learning from those patterns, making recommendations, and then being able to act on that. And then the third point there, are you optimizing for average performance, or are you able to react when things change? Can you adapt in real time? One of the things, for better, worse, and different, that we saw over COVID is with these shakeups of the supply chains, and we're kind of seeing it again here with tariffs. When you have those shakeups in supply chains, let alone just changes in market demand and market preferences and things like that, how fast can you react to that? And so if you're constantly running the plant to static set points and conservative buffers to kind of be safe, you are probably leaving a lot of efficiency, throughput, quality gains, kind of on the table. And those are the types of things that we can leverage AI to be able to build better set point strategies, build AI to be able to run those parts of the process, and be able to let you adapt faster to those changing conditions.
Yeah, you said something there that I thought was pretty insightful that I hadn't thought about quite that way is, how you prioritize where you're going to spend your continuous improvement money, on a continuous improvement mindset organization. I've certainly worked with my share of those over the years and using AI as a method or using the process you guys are using to say, wait a minute, how do we zero in and really find the hot spots so that, we're not just letting the loudest voice decide where we focus. We're using data to say, okay, there's 500 different things we could work on, but these 50, based on the data and the hotspots, are probably where our real opportunities are from a Pareto analysis perspective. So I find that pretty fascinating. So we're going to pivot now to the second part of the podcast, which I think will be fairly short. Kind of get into, okay, so the audience is saying, okay, yep, we got an opportunity here. Yep, we got issues with tribal knowledge. We are going to have turnover. We could certainly be better. What's your sage advice that's not easily Googled for the answers of, okay, so we got these challenges. What do we do? How do we go from here to actually implement and close the gaps on those things? And I think this is you've actually shared a lot of that with us in bits and pieces along the way. So maybe we can kind of put a bow on that. How do you go after this now?
Yeah, for sure. And yeah, you're right. I gave away some of it, the ending already, as I was talking. But so, for that first one about tribal knowledge, if you've diagnosed that that's a problem for you guys, you're losing that expertise, which, like I said, almost every one of my customers is saying that. We're looking to convert historical operational data into expert knowledge, capture that expertise through that process of machine teaching. And then third, use autonomous AI to model that expert behavior. So we really see autonomous AI as we think when we look backwards in time, this will be one of those pivot points, like when we moved, from, pneumatics and relays and then, to transistors. Each one of those represented a big change, a turning point in the history of manufacturing. We do see autonomous AI as that. I think when we look back, we're going to say the adoption of autonomous AI was that pivotal of a change. The second one, when we talk about decision-making bottlenecks, typically the advice that we're giving, shift from reactive to proactive decision-making. And how do you do that? And how could you do that? Well, the way that you do that is you adopt predictive models and to be able to act before those problems arise, right? Predictive models have this cool ability to effectively make you like a future teller, like a seer. You can actually look in your crystal ball and say, this is how things are going to happen in the next hours and days. That's what predictive models are able to give you. We're able to adopt those predictive models and change that culture to be more proactive. Um, Introduce AI in a decision support mode always before direct control. We don't want and I still hear AI vendors, primarily those AI vendors that have come from the IT world and don't really understand the OT world, that are saying we're going to go to closed loop control right away. I'm like, there's not a single one of my customers that's going to let you do that, right? So always start with decision support mode first. That's where it's looking over the shoulder, but there's a human in the loop, and the human is changing those set points. That's where you want to start. Then after, a certain amount of burn-in, after a certain amount of validation, and about 75% of my customers want to get there, now we can go to direct control. Now we can go to where we're closing that loop and the AI is setting those set points on its own, but not until we've had a long time to validate the process and make sure that the AI is doing what we want. And then finally, pairing that autonomous AI with control system integration, to get to that real-time action. So once we've earned the trust in decision support mode, now we can go ahead and put those AI systems into where they are controlling those control systems directly. As far as the third diagnostic, so if you recognize that you are missing out on optimization opportunities, we can leverage simulations to model what if scenarios. And I know that most of my customers don't have comprehensive simulation. That's okay. When I say simulation, we're not talking about necessarily big, expensive first principles sim implementations. What we're talking about is leveraging data to build what are called data-driven models, which are simulations of the real world built on data from the real world. And with those, we can simulate the processes in the factory at a good enough level to be able to do these what if types of analyses. So we can do that in a much cheaper way than, adopting a full, physics-based simulate. We don't need that physics-based simulation of the plant. Secondly, leveraging predictive set point AI to anticipate and adjust before those deviations occur. So predictive set point is the ability where we can effectively find correlations between set points and high quality. So if you're not at high quality, here's what we can recommend that you move the set points to. It's not as capable as autonomous AI, but we can implement it faster than autonomous AI. So with predictive set point, now we can anticipate and adjust before we get into those deviations. And finally, so important, I saved it for last, establish KPI baselines. And then go and challenge those baselines with the AI. The KPI, so many customers say, how can I be successful with AI projects? Well, the answer is have you established what your baseline KPIs are today? Because if you haven't, you're never going to know whether or not the AI was successful or not. So it's one of the first things we do is we say, okay, what's your throughput today? What's your scrap today? What's your energy usage today? Now let's put the AI on top, and now we can see, oh, there's a double-digit percentage. That's worth a couple $1,000,000 a year, isn't it? Now we can help justify these projects and help be able to build that momentum to get those future AI projects going. So establishing those KPI baselines is so critical.
All right, cool. So before we get into wrap up, I'm going to ask a question that popped into my head. Are you familiar with the out of the Six Sigma toolboxes that is a pretty robust technique called design of experiments? Are you familiar with that?
Yes.
All right. So for the audience that's not familiar with it, it's basically a scientific way of looking at a process and determining all the variables that affect the output of the process and then running experiments to isolate which variables have the biggest impact on your process. So it's obvious to me that in effect you can run, AI does in effect run DOE,
Mhm.
but the question is, can it do it dynamically? In other words, the variables change, right? So where we did the original experiment, it basically was these things really determined what was driving the variation in the process that we have to control the tightest. But things drift, right? We have different equipment coming into play, different materials being fed in, all kinds of things are going on. Have you been able to do dynamic DOE? We can actually on the fly change the priorities for controls?
So it's interesting. The AI is good at some things and not so great at other things. So one thing that it's actually very good at is identifying. AI is very good at identifying what the important parameters are, in some cases without having to do a full DOE. However, I'll give you a counterexample to that. So we had a situation, we had a glass bottle manufacturer, and they were looking to adopt autonomous AI. In order for us to build an accurate enough simulation, we realized we didn't have all the data that we needed. We needed a broader state space. And so we built a DOE playbook for them. And so every time they were coming into downtime or a maintenance window, they would actually make bad bottles on purpose. So they would pull for a page from that playbook, that DOE playbook, and they would make bad bottles on purpose so that we could capture what happened in the historian. Now we could use that to make that simulation better. We can fill in some of those gaps in the state space with that. But once you've given that to the AI, it's actually really good at dynamically being able to respond to situations, even situations that are novel, situations that it's never seen before. It's actually really impressive with how it's able to navigate those unique challenges. So.
Very cool. Well, Brian, this has been fantastic. You've exceeded my expectations out. So we'll get into wrap up now. So if folks want to get in touch with you, pick your brain, ask your questions, how do people reach you?
Yeah. The easiest way is on LinkedIn. So you can, they can find me, BryanDebois, Bryan DeBois. Just search for me on LinkedIn and I'll pop right up. And the other way is to check out the Rovisis website, my employer. So
There we go.
Rovisis.com, ROV as in Victor, ISYS, Rovisis.com/AI will take you right to the AI portion of our website.
Well, I'm imagining if anybody listened to this, they're going to be checking that out for sure.
I sure hope so.
All right. Thank you, Bryan. Great job.
Thanks, Ron.
All right. So thanks for joining us for this episode of Metapod. Be sure to like Metapod and share it with your network. More viewers is good, helps support, getting this good information out from thought leaders like Bryan to the world. So thank you again for joining us.
Thank you for joining Metapod. For requests on topics or to ask questions, you can connect with Ron Crabtree 3 ways: via email at metapod@metaexperts.com, via LinkedIn, or by calling him directly at 734-425-1455, extension 103. Lastly, if you love the show, please consider leaving a 5-star review on your favorite podcast app. We truly appreciate all your support.